Hi, this is Paul, the SDR guy, and today we're going to learn about analog to digital converters. The acronym that's used is ADCs. These are very, very important components in our modern software-defined radios. Let's next take a look at what we're going to be learning about with a bit of a preview. The Nyquist Theorem states that to accurately reconstruct an analog signal from its digital sampling, the sampling rate must be at least twice the highest frequency present in the original signal. I should mention that I used ChatGPT to create the graphic that we're now looking at. The things I want you to notice about this particular graphic is in red, we're graphing out a sine wave, one cycle of a sine wave. Notice that it is continuous. What do I mean by continuous? Well, there are no breaks in the line. So let's now look at the black dots. These are discrete samples. And if you'll notice here that these are not continuous, and we will see a bit later in our video today that some of these dots don't fall exactly on the red line. The number of discrete values an analog to digital converter can provide is determined by 2 raised to the nth power. N is the number of bits in the ADC. Notice on this slide, we're saying that the number of discrete steps, if you will, is dependent on the number of bits. Now the E that you're seeing here, for example, 2E2, that means 2 exponent of 2. So if you have 2 bits, you have 4 different steps. If you have 8, you have 256. If you have 12, you have 4096. And if you have 16 bits, you have 65,536. Next, we're going to bring up our browser, and let's look over here. And as always in my videos, I'll put the links to these 2 web pages. I'll put the link to my GitHub repository so you can easily download my Flowgraph. But the thing I wanted to bring to your attention here is notice that this particular SDR uses 2 bits. And if you want to look at a fairly comprehensive list of SDRs, we can take a look at this Wikipedia page. And notice in this column, RX means receive, ADC, analog to digital converter, bits, and I suggest you go through this list and kind of familiarize yourself with the SDRs that are available as well as their capabilities. Let's now bring up our GNU Radio Flowgraph, and I've added a few extra things in the Flowgraph, but the most basic things that you need is a signal source, and since we are not connected to physical hardware, you need a throttle. And then after that, we have a quantizer. And what this block is going to do, it's going to simulate for us SDRs with various number of bits. And we are going to be looking at the output of this both in the time domain, so we're using a time sync, and the frequency domain. Now, we're also using a GUI chooser, and we're going to be taking a look at quantization errors using 2, 8, 12, and 16 bits. At the very end of the video, I will enable these boxes that are grayed out and send the output to an audio sync. So, without further ado, let's go ahead and run this flow graph. And so here we go. And what I'm going to do is I'm going to trigger this by selecting normal. And so we have one complete cycle frozen in time here. And I want you to notice that the blue line that you see here, this is a continuous sine wave, and that we are going to be approximating this particular sine wave. So we have a total of 4 different steps. And so in the positive direction, you see a step here, you see a step here. And in the negative direction, you see a step here, and you see a step there. So that's a total of 4 steps, or four. These ultimately come out as numbers, which then are used by our digital signal processing software. So this is in the time domain. The next thing I want you to notice is if we come down here to the frequency domain, and if we look at this, the top of this signal, notice it's approximately minus 15 dB. Now, all this stuff that you see down at the sides are noise, and more specifically, this is quantization noise. And so notice that the highest peak is about minus 35. So the noise is only down about 20 dB. So make a note of that. And what we're going to do now is we're going to move on to 8 bits. So you will recall from an earlier slide that that's going to give us 256 steps. So let's go ahead and select that. And let's go ahead and return our trigger to free for a moment. And in fact, let's go ahead and turn it back to normal. So the thing I want you to notice here, there are still stair steps here, and we can left click here and make a rectangle and zoom in. But for here, for the 12-bit and 16-bit, you can kind of take my word that the stair steps are still there, but they are just much smaller. Now, another interesting thing to note here is when we move to 8 bits, notice that this quantization noise or harmonics is much less. So we're sitting here at about minus minus 15 roughly. But look, when we come down here, then it's minus 85. So there's a very considerable difference in the quantization noise. So let's move on to 12-bit. And you may not have noticed, but the scaling has changed, and again, the quantization noise is much, much lower. Well, let's go ahead and move to 16 bits. And I'm going to need to scroll down. So there's a huge difference in the amount of quantization noise. And when we're talking about these ADCs, we have some other issues with them. We have thermal noise and some other things, but I think that this will suffice for what we're looking at today. So let's go ahead and close down or stop our flow graph. And the last thing that I'm going to do is I've connected an audio sync. And let's go ahead and select the group, and then let's right click and enable. And I'm going to turn up my audio on my computer. And the thing I want you to notice here is we're using a rational resampler because our sample rate is 2,000,048 samples per second, and that's going to go through this rational resampler. And if you take this 3/32 and consider this a fraction, if we multiply the 2.048 million samples a second times the fraction 3/32, that will give us 48 kilohertz, which is what most PC sound cards use. This multiply constant block, this is just simply a volume control. So let's go ahead and run it. And we're going to start out and we're going to be hearing the 2-bit quantization. And let's listen to this same thing if we bump it up to 8 bits. How about 12? And lastly, 16. It's kind of hard to hear the difference there, so let's go ahead and stop this. So this concludes what I wanted to cover with you today. And with that, this is Paul, the SDR guy. Please consider liking the video and subscribing to my channel, and have a wonderful day.